Bismillahirrahmanirrahim. Assalamu alaikum students. How are you? Hope you will be fine. Now we will start revision of chemistry second year, and we will first revise the chapter number 11, alcohols, phenols and ethers for the examination point of view. Alcohols, phenols and ethers. First of all, introduction. We will give introduction. Alcohols, phenols and ethers are classes of organic compounds which are much closer to water in structure and hence considered as derivatives of water. Look here, all these three structures resemble with each other and resemble with water. This is the structure of water, this is structure of alcohol, and this is structure of phenol and ether. All these three structures resemble to that of water. Only difference here, alkyl group is attached instead of hydrogen atom, and here phenyl group is attached and here alkyl group is attached. Otherwise other formulas same. Now in these, first of all we will study alcohols. General formula of alcohol is ROH. Classification of alcohol: primary alcohol, secondary alcohol, tertiary alcohol. This is the basic formula of general formula of primary alcohols. Primary alcohols are that in which alcoholic group is attached to that carbon atom which is further attached to singular carbon atom or no other carbon atom. And secondary alcohols are that in which OH group is attached to that carbon which is further attached to the two other carbons. And in tertiary alcohols, OH group is attached to that carbon which is further attached to the three other carbon atoms. This is the three classes of alcohols. And now we will discuss formula, common name, IUPAC name, common name, formula of methyl alcohol, common name CH3OH, common name methyl alcohol, IUPAC name is methanol. Ethyl alcohol, CH3CH2OH is formula, common name is ethyl alcohol, and ethanol is IUPAC name. And next is propyl alcohol, CH3CH2OH propyl alcohol, 1 propanol, and so on. Now we will study the industrial preparation of alcohols and methanol, and we will study we will revise the topic methanol. Formerly methanol was prepared by distillation of wood. That's why it is also called as wood spirit. Nowadays methanol is prepared from carbon monoxide and hydrogen or water gas as follows. This is the formula of water gas. Mixture of carbon monoxide and hydrogen is called water gas. When it is passed on in the presence of, when they react in the presence of zinc oxide, chromium oxide catalyst, and temperature is 450 degrees centigrade, methanol is formed. This is the flow sheet diagram of the formation of methanol. This is gas purifier and this is compressor. When it is passed through the compressor, and then it is catalytic tower. Here catalysts are react with the carbon monoxide and hydrogen water gas, then it is condensed and at last, and methanol is prepared. Flow sheet diagram and ethanol. Flow sheet diagram for any reaction is very important for getting marks. I think it is the summary of whole topic, so it is good and it is very necessary to draw the flow sheet diagram if you want to get maximum marks of this topic. Now we will discuss ethanol. Preparation of ethanol from molasses. Ethanol is prepared on industrial scale world over by the process of fermentation. Fermentation is a biochemical process which occurs in the presence of certain enzymes secreted by microorganisms such as yeast Optimum temperature for this process of fermentation is 25 to 35 degrees centigrade. Moreover, proper aeration, dilution of solution, and the absence of any preservatives are essential conditions for fermentation. In Pakistan, ethanol is prepared by the fermentation of molasses, starch, grains, or fruit juices. And from molasses, these steps take place. First of all, C12H2211 is the formula of sucrose plus water. Invertase enzyme convert this into two molecules of glucose. Glucose further in the presence of enzyme convert into ethanol and plus carbon dioxide. This is preparation from molasses. And now we will discuss the preparation from starch. C6H10O5 plus water molecule react in the presence of a diastase and it is converted into sucrose. Sucrose in the presence of water gives, in the presence of maltose gives glucose. Glucose in the presence of zymase converted into ethanol and carbon dioxide. Now, denaturing of alcohol is important from short questions, and sometimes ethanol is denatured by addition of 10% methanol to avoid its use for drinking purpose. Such alcohol is called methylated spirit. A small quantity of pyridine or acetone may also be added for this purpose. And next is physical properties of alcohols. Physical properties mean these alcohols. Lower alcohols are toxic liquids and sweet smell and burning taste, soluble in water due to hydrogen bonding. Because in water also hydrogen bonding, and alcohols have also ability to form hydrogen bonds, so these dissolve in water, and therefore these are soluble in water. Reactions of alcohols. Reactions in which CO bond is broken. Alcohols react by means of two different ways in which carbon oxygen bond is broken. Here carbon and oxygen bond is broken, and other reactions in which cleavage of hydrogen oxygen bonds, in which hydrogen oxygen bond broken. First of all, we will discuss that reactions in which CO bond is broken. C2H5OH plus SOCl2 in the presence of pyridine gives C2H5Cl plus SO2 plus HCl. C2H5OH plus HCl gives C2H5Cl ethyl chloride plus water. Ethyl alcohol plus ammonia gives ethylamine plus water. Now, other category of reaction involving cleavage of hydrogen oxygen bonds. Ethyl alcohol plus sodium gives sodium ethoxide plus hydrogen. Ethyl alcohol plus methyl magnesium iodide, this is Grignard reagent, and gives methane plus magnesium iodine and OL. C2H5. Ethyl alcohol plus acetic acid gives CH3CO C2H5 ethyl acetate plus water. And now we will start oxidation reactions of alcohols. Oxidation of alcohols gave very useful products. Oxidation of alcohols convert them into aldehydes and ketones. In this oxidation by the oxidation of alcohol we get aldehydes and ketones. The best reagent for this purpose is acid dichromate. This is acidic condition H2SO4 and dichromate. CH3CH2OH plus atomic oxygen gives CH3CHO acetaldehyde plus water. And second is secondary alcohol. When oxidation takes place, then ketone is formed, and when tertiary alcohols oxidize, then alkenes are formed. You can see the products by the oxidation of primary alcohol, secondary and tertiary. By the oxidation of primary alcohol, aldehydes are formed. By the oxidation of secondary alcohols, acetones are formed. By the oxidation of tertiary alcohols, alkenes are formed. These are very important reactions from examination point of view. You have to prepare it very well. Now, next reaction, chemical reaction of alcohols is dehydration. When alcohols are dehydrated, alkenes are formed. Here, when conditions are ethyl alcohol plus concentrated sulfuric acid, temperature is 180 degrees centigrade, ethane is formed plus water. Removal of water, dehydration, removal of water, there removal of water take place. So next condition is ethyl alcohol when temperature is 140, concentrated sulfuric acid diethyl ether is formed, and diethyl ether is formed. Now, the distinction between primary, secondary, and tertiary alcohols can be done as follows by the Lucas test. Lucas test is that primary, secondary, and tertiary alcohols are identified and distinguished by reacting them with concentrated HCl in anhydrous ZnCl2. An oily layer of alkyl halide separates out in these reactions. First, tertiary alcohols form oily layer immediately. Here timing will be counted here. Formation of oily layer. Tertiary alcohols immediately, and secondary alcohols form oily layers in 5 to 10 minutes. Primary alcohols form oily layer on heating. And these are the reactions. Alcohols with HCl gives alkyl halides in 3 cases formed, but the timing of forming alkyl halide is different. Distinction between methanol and ethanol. Ethanol gives iodoform with iodine in the presence of NaOH. Formation of yellow crystals indicate that alcohol is ethanol. Methanol does not give iodoform test. And this is the reaction of ethyl alcohol plus iodine plus NaOH gives CHI3 iodoform plus sodium formate plus sodium iodide plus water. Iodoform formed in case of ethyl alcohol, but in case of methyl alcohol, iodoform does not form, no yellow precipitate form. It does not give this iodoform test. This is the distinction between this is the method how we can distinguish methanol from ethanol. And uses of alcohols. Methanol is used as a solvent for fats, oils, paints, varnishes. It is also used as antifreeze in the radiants of automobiles and for the denaturing of alcohol. Ethanol is used as a solvent, as a drink, and as a fuel in some countries. Moreover, it is used in pharmaceutical preparations and as preservative for the biological specimens. This is this was their topics which are important from examination point of view. Dear students, please prepare it well for the examination point of view. Thank you.